So before I show you how to complete the investigation or fill in the chart on the back of this page, I just want to work through and do some explanation of the note on the beginning. So we're going to take a look at investigating exponential derivatives. So we really want to learn how to find the derivative of something that is exponential. So we're going to go back to our definition of the derivative, which is the limit as h approaches 0, f at x plus h minus f at x over h. Remember, h approaches 0 because h is the distance between the 2 points being a secant, 1 point being a tangent. So as the distance between the 2 points approaches 0, we go from secant to a tangent, and this is our slope. The top is the rise, and the bottom is the run. So we're going to look at an exponential function. So we're looking at y equals b to the x. So then f at x will be b to the x, and I'm going to use that and put it in there. F at x plus h will be b to the x plus h, and I'm going to put that in there. So now my definition for finding the derivative of something that's exponential becomes f prime at h equals the limit as h approaches 0, b at x plus h minus b at x all over h. All I did there was replace the function itself with a general exponential function, b to the x. Now in the next step, instead of having b to the x plus h, we rewrote it as b to the x times b to the h. That is one of our laws of exponents. If you're multiplying powers, if I had b to the x times b to the h, I would keep the base b and add the exponents. So we've really just done that backwards. We had b to the x plus h, so we're rewriting it now as a power, because then what I can do is both terms have a b to the x in them, so I'm going to common factor out a b to the x. So I have b to the x bracket b to the h, because when I factor b to the x out of b to the x, b to the h, all I'm left with is the b to the h. Then I have minus 1, because when I factor b to the h out of itself, it's 1 all over h. Now, this b to the x is multiplying the b to the h minus 1 over h. There's no h in this b to the x, so it does not have to follow the limit notation. So in the next step, I brought it out in front of the limit because there's no h in it. So it doesn't have to follow the limit because we're never going to put or try to put h equal to 0 or look for a strategy in that part. Well, b to the x is f at x. So this is kind of cool that the function itself is part of the derivative. Now, if I looked at, I have this, and this is my derivative, or this is the slope of any tangent for b to the x. I'm going to look at x equal to 0 as a specific point. So I'm going to put 0 everywhere in here where there's an x only. So f prime is 0, or the slope of the tangent at the point where x equals 0 is b to the 0 times the limit as h approaches 0, b to the h minus 1 over h. Because there was no x in this part, it didn't impact it. But now, b to the 0 equals 1, because any base to the exponent 0 equals 1. So the slope of the tangent at 0 is equal to this limit as h approaches 0, b to the h minus 1 over h. So f prime at 0 is equal to this limit that keeps popping up. So this limit gives us the slope of the tangent for an exponential when x equals 0. So what I've done here is just kind of give you a specific example. So I've graphed f at x equal to 2 to the x. I went to the point where x equals 0, and I graphed the tangent. I picked up 2 coordinates in my program of the endpoints, and then I had it calculate the slope. So if it's 2 to the x, then the limit as h approaches 0, b to the h, it'll be 2 to the h in this case, minus 1 all over h, should get close to 0.75 because that's the slope of the tangent at 0. And again, I played with this approximately. It might not be quite 0.75, but that's a reasonable estimate. So this makes exponential functions fairly interesting because the derivative is just the function itself, f at x, that's our b at x right there, times the slope of the tangent at 0, f prime is 0. So what would be really cool is if the slope of the tangent at 0 was equal to 1, because then this f prime at 0, or the limit as h approaches 0, b to the h minus 1 over h would equal 1 for a certain base, that would make that part go away. And f prime at x would just equal f at x. So the derivative would just be equal to its function itself. However, the slope of the tangent changes depending on what the base of our function is. For y, or the b equal to 2, our slope of the tangent was about 0.75, not quite 1. We want to see if there is a base or a b value that would have a slope of 1 at x equal to 0. Now the problem is, in this definition, or have it down here, h can't really equal 0 because we don't have a strategy for eliminating that. So we're going to use a number close to 0, 0.0001 for our h, and we're going to change our b value. So the first b value we're going to start with is 1. So I'm going to calculate the limit as h approaches 0, 1 to the h minus 1 over h. I can't calculate this, but what I'm going to do is use 0.0001 to estimate it. So I'm typing in 1 to the exponent 0.0001 minus 1 divided by 0.0001. I'm going to do it in my calculator. Please make sure to remember that there are implied brackets around the top of any fraction, so I'm going to hit the equal sign before I do the divide. So 1 to the exponent 0.0001 minus 1 equals, divided by 0.0001, and it's giving me an answer of 0. It's not quite 0, but I'm going to go with it. Where we're going to start to get more sensible answers is now I'm going to do base equal 2. So I'm going to do 2, I'm putting that in for my base. I'm still using h as 0.0001 minus 1 divided by 0.0001. So 2 to the exponent 0.0001 minus 1 equals, divided by 0.0001 is 0.69. So I got 0.75, this is 0.069. It's close enough that that's just from me picking random points and playing with this until it looked like a tangent, and from us not quite using 0 here. What I would like you to do now is repeat this process for 3, 4, 5, and 6. Write your answers in here, and always remember that we're looking for the one that has a slope of 1. These are the slopes of our tangents. So we're going to use that information to finish this activity. What I would like you to do is to submit your work from this page. You don't have to submit the front page if you don't want to, but this page here, your chart and your answers to these questions should be submitted to the Dropbox.